Welcome back, everyone. Unit 2 of AI. We will continue with the blind search. Example for blind search, we start with uniform cost search. This algorithm comes into play when a different cost is available for each edge. The primary goal of the uniform cost search is to find the path to the goal node, which has the lowest cumulative cost. Uniform cost search expands nodes according to their path cost from the root node. It can be used to solve any graph or tree where the optimal cost is in demand. A uniform cost search algorithm is implemented by the priority queue. It gives maximum priority to the lowest cumulative cost. Uniform cost search is equivalent to a breadth first search algorithm if the path cost of all edges is the same. Consider this a graph where you have a source node and there are multiple goal nodes. So how to reach to this goal node from the source node based on this uniform cost search we will discuss further. Step 1 will be start with start node and check we have reached any of the destination nodes, that is no number of source nodes that can be continued. Now next step is we reach all the nodes that can be reached from S1, example A, B, C and D. And since nodes S has visited, thus added to the visited list. Now we select the cheapest path first for further expansion, that is A. Here if you see the step 3, node B and G1 can be reached from A, and node A is visited already, we will move to that visited list. Since G1 is reached, but for the optimal solution, we need to consider every possible case. Thus, we will expand the next cheapest path, that is source node, which is equivalent to D, which is diverting to D. So while traversing from S to D, now the D has visited, thus it goes to visited list. And now since we have three paths with the same cost, we will choose alphabetically, thus we will expand node B. If we consider B, we can reach node C after this B is reached. Now the path with the minimum weight is S, D and C. And the B is now visited node. From C, we can go to G2 and F node with 5 and 7 weights respectively. Since S is present in the visited node list, thus we are not considering C to source path. Now C will enter the visited list. Now the next node with the minimum total path is S, D and E. Thus we will expand E further. From E, we can reach only G3. E will move to visited list now. Now the minimum cost is S, D, C and G2. And also G2 is one of the destination nodes, thus we will find our path. In this way, we can find a path with the minimum cumulative cost from source node to goal node, and the corresponding path will be what? S, D, C and G2. And implementation will be the fringe is equivalent to Q ordered by path cost equivalent to breadth first if all the step costs are equal. Breadth first search is only optimal if step cost is increasing with depth or constant. Can we guarantee optimality for any step cost? So that uniform cost search will do for that with expanding the nodes with the smallest path cost G of n. So what are the steps that are involved in uniform cost search algorithm is expand the nodes with the lowest cost from the start node, and completeness is yes, it can complete if the cost of the each step is greater than or equal to source node, and which should be greater than or equal to 0. There should not be any negative cost. Optimality, with respect to optimality, same as above nodes are expanding in increasing order of cost. Time and complexity is big O of b power 1 plus fc plus s to the power of b. If all step costs are equal and uniform cost search is equivalent to what? Breadth first search algorithm. So where b is the cost of optimal function. And time complexity, if you consider for uniform cost search, let C star is the cost of the optimal solution, and epsilon is the each step to get closer to the goal node. Then the number of step is C star divided by epsilon plus 1. Here we have taken plus 1 as we start from state 0 and end to C star divided by epsilon. Hence, the worst case time complexity of uniform cost search is big O of b power 1 plus c star divided by epsilon. Space complexity. With the same logic is for space complexity. So, the worst case space complexity of uniform cost search is big O of b power 1 plus c star divided by epsilon. If you consider the uniform cost search as a conclusion, uniform cost search is a search algorithm used for traversing a weighted tree or graph. This algorithm comes into play when a different cost is available for each edge. The primary goal of the uniform cost search is to find a path to the goal node which has the lowest cumulative cost. Uniform cost search expands nodes according to their path cost from the root node. It can be used to solve any graph or tree where the optimal cost is in demand. A uniform cost search algorithm is implemented by the priority queue. It gives maximum priority to the lowest cumulative task. If you take an example with the uniform cost search algorithm with this corresponding tree, which has 4 levels, how the algorithm works is uniform cost search returns a solution or a failure, and a node state will be a node, and the problem of initial state is path cost should be assigned as a 0 initially, and a priority queue ordered by path cost with the node as the only element is considered as a frontier, an empty set will be explored, and in the loop we have to check again until we are reaching the solution or a failure for checking that with empty, then return failure. If a pop is equivalent to the node, then check if problem goal test, then return a solution and add node dot state to be explored state. And for each action, again check whether problem of action and continue this. Then you after reaching the solution, child node will be a child. If child state is not explore, then insert a new frontier. Else, child state is in the frontier with a higher path cast. Then replace the frontier node with the child. So this is how uniform cost search should be implemented. We see the working of uniform cost search. Start from A and expand and nothing will be expanded and the frontier will be A. Now expand your A and then the frontiers are B and C. Expanded is A. Then frontiers now D, C, E. As per the priority queue, expanded now what? A and B. Here, if you see the frontiers for your next stages C, E, E, and G. Now the expanded nodes are what? A, B, D. Now the D should be expanded with G and E. So if you consider uniform cost search algorithm, with respect to the table, it can be done easily. There is a priority queue. Consider a table with 3 elements, priority queue, explode, states, and parent. So whatever you create a node list with whatever the nodes that are being expanded. So the first node that has been expanded is S0. And then S with the pathcast is what? 0. And whatever the suffix that are added after the nodes, they are the pathcast. And S will be expanded with respect to what? What are its children? A, B, C. So A, B, C will be added here in the ascending order of their pathcast. So pathcast of B is 1, pathcast of A is 3, and pathcast of C is 8. So B should come first, then A, then C. Next, so what is the first in the frontier of this S naught? B1. So B1 should be explored. So correspondingly, whatever the explored nodes that are been added in the tabular column as shown in here, shown in the figure, and its corresponding parent nodes also you just mention in the parent list, which is going to give us the final destination path. Then B1 should be explored, and B1's children are what? G. Okay, and G's path from the source node is what? 21 and 21, and already the podcast, the nodes that are not explored are from the previous list, A3 and C8 also should be added among G21, A3, C8. You just arrange them in the ascending order, whichever is the least. Then here, which is the path, which is the node that has to be expanded now adjacent to B1 is A3. So A3 is having the smaller pathcast that should be expanded. So if you see A3 here, if you expand A3, what are the nodes will come? D, E, and G. And D, A to D, its pathcast for D from the source node will be 6. Similarly, for E, it is 10. For G, it is 18. So among these three, and already C8 and G21 will be added here. Among all these five nodes, whatever the least pathcast to highest pathcast, you just arrange them in the ascending order. So after that, you can able to find here D6 will be the lowest pathcast, and that should be expanded. So similarly, all the nodes pathcast will be expanded. And finally, after expanding all the nodes, you can able to see here is G13, G18, G21 are the final goal cast you will be having. And here, if you see among goals with cast 13, 18, 21, goal with 13 is the least cast, and that should be the path. And goal 13, if you see here, and its parent will be G, and its parent is S. So the path for reaching the goal 13 will be SCG, and number of nodes expanded for that will be 7. This is how uniform cost search will be working. This is the end of uniform cost search. In the next class, we'll discuss about depth limited search. Thank you for watching.